Hi friends, my name is Jayavardhan. I am ECE department. Today my topic is specialty of ferromagnetic materials compared to other magnetic materials. Ferromagnetic materials are those materials which exhibit a spontaneous net magnetization at the atomic level even in the absence of an external magnetic field. When placed in an external magnetic field, in the absence of external ferromagnetic materials are strongly magnetized in the direction of the electric field. This is the diagram of ferromagnetic materials. Antiferromagnetic materials. Examples include hematite metals such as chromium, alloys such as iron, manganese, and oxides such as nickel oxide. There are also numerous examples among high nuclearity metal clusters. Magnetic properties of ferromagnetic materials. Ferromagnetic materials are spontaneously magnetized, but this does not mean that every last movement is oriented in the same direction. Certainly, the overwhelming majority are, and at 0K, all movements are theoretically predicted to be perfectly aligned. In this case, the magnetization saturates or reaches its maximum value. Above 0K, some of the spins oriented in random directions, a trend that accelerates as the temperature rises higher and higher. Finally, at the Curve temperature, the magnetization vanishes. Multi-ferromagnetic materials. Ferromagnetic materials are commonly used for non-violent information storage in tapes, hard drives, etc. They are also used for information processing due to the interaction of electric current and light with magnetic order. Ferroelectric find applications due to their large piezoelectric coupling constant, that is, the coupling between an electric field and strain. This effect is utilized in devices such as capacitors, microphones, and transducers, where a voltage can generate strain and vice versa. Ferromagnetic materials not only exhibit piezoelectric coupling, common for most materials that lack inversion symmetry, but also possesses memory functionality. Differences between ferromagnetic materials and paramagnetic materials. Ferromagnetic materials. Substances which are strongly attracted by a magnet are called ferromagnetic materials. Paramagnetic materials. Substances which are weakly attracted by a magnet called paramagnetic materials. Advantages of ferromagnetic materials. Resistance is high. Materials are cheap. High stress is low. Loss is low. Electrical resistivity is high. High permeability. Properties of ferromagnetic materials. The atoms of ferromagnetic substances have permanent dipole moment present in domains. Atomic dipoles in ferromagnetic substances are oriented in the same direction as the external magnetic field. The magnetic dipole moment is large and is in the direction of the magnetizing field. The intensity of magnetization is very large and positive and varies linearly with the magnetizing field. Hence, saturation depends on the nature of the material. Ferromagnetic substances are strongly attracted by the field. So, in a non-uniform field, they tend to stick at the poles where the field is strongest. When a ferromagnetic substance is liquefied, it loses ferromagnetic properties due to higher temperature. Thank you.